Hello grade 9s, this is Mr. Miller and welcome to lesson 9.3 on solving multi-step inequalities. So for starters, we're looking to just solve these inequalities, and keep in mind that solving an inequality follows the same steps as solving an equation. The only difference is if we multiply or divide both sides by a negative, we have to change the direction of the inequality. So since there are no fractions, no decimals, no brackets, no simplifying to do, all we have to do with the first one is move the variable terms to one side. So I've decided to move them to the left. So I've taken this 2x and subtracted it from the left. I'm going to subtract it as well from the right. I end up with a single x on the left. And now the minus 5, I'd like for it to go to the right. So I'm going to add 5 to this side to get rid of it from the left. And I add 5 to the other side. 4 plus 5 is 9. And that's the solution to the inequality. Let's take a look at this next one. Here we have some decimals. So if you're not keen on working with decimals, you can start off by multiplying both sides of the equation by 10. Don't forget to use your distributive property, so you're doing 10 times 4x as well as 10 times the 3.2. What you get as a result is 40x plus 32, no more decimals. Same thing on the other side. 10 times 2x is 20x, and 10 times 1.4 is 14, so this no longer has any decimals anywhere in the equation. From here, it's very similar to what we started with in 1a. So you want to move the variable terms to one side, constants to the other side, and divide by the coefficient of the variable. So I subtract 20x from both sides. That leaves me with 20x on the left, and I subtracted 32 from both sides. That leaves me with negative 18 on the right, and divide both sides by 20. It gives me x is less than negative 0.9. Notice then these first two examples here, we haven't changed the direction of the inequality. It stayed greater than, greater than, greater than, greater than, greater than the whole time, because all I was doing was adding and subtracting things from both sides in this case. And in this case, it stayed less than all the way through because I was just adding and subtracting things. The only time I divided was here in the last step, and I was dividing by a positive, so I don't need to reverse the direction of the inequality. So now let's move on to the next set and take a look at how they play out. So we've got an equation here with fractions. If you don't mind working with fractions, that's one thing, but if you want to get rid of them, denominator of 4, denominator of 2, least common multiple is 4. So I've decided to multiply both sides by 4, first of all. So remember to use your distributive property after you do 4 times 3/4 x, which gives you 3x, and 4 times 8 is 32. On the right, it's a little bit different because there already was a half times a bracket. So you only have to do the 4 times a half, which gives you 2. Of course, from here, you need to expand some brackets. So I'm doing 2 times 3x is 6x, and 2 times negative 5 is negative 10. I just need to move my variable terms to the left. So I've subtracted 6x from both sides. And as a result, I get negative 3x. So 3x take away 6x is negative 3x. Now I want to have my constant terms on the right. So I'm going to subtract 32 from both sides. Negative 10 take away 32 gives me negative 42. And last step, I'm going to divide both sides of the equation by the coefficient of the variable. Now, because the coefficient of the variable was a negative and we're dividing both sides by a negative, we must reverse the direction of the inequality. So negative 42 divided by negative 3 is positive 14. The less than or equal to switches to greater than or equal to. Now let's take a look at part D. No fractions, no decimals, but we do have brackets. We need to expand the brackets first. So using the distributive property, 6 times 5, 6 times negative x, 7 times x, 7 times negative 5. Now we put the variables to one side, and I've decided to move my variables to the right this time. So here's a variable on the left. I want to get rid of it from here, so I add 6x, because those things will add to 0. 7x plus 6x gives me 13x. Now I want to have constants on the other side, so I'm going to have to take the negative 35 and add 35 to it to get 0. So adding 35 to the left, we end up with 65. Now we divide both sides of the equation by my favorite number, my lucky number, 13. And as a result, we get x is greater than or equal to 5. Well, you might be reading this from left to right, 5 less than or equal to x, but you could also read it as x is greater than or equal to 5. Next, in number 2, the instructions are solve and draw a number line to represent each solution. So to solve this equation, we just move variables to the left. So we get 4x plus 4 less than or equal to 12. Constant terms to the right. So we end up with 4x is less than or equal to 8. And dividing both sides by the coefficient of the variable, we end up with x is less than or equal to 2. On the number line, what that looks like is this. So we're going to have a closed circle here because we do want to include the x equal to 2. And we want to shade to the left because its x is less than 2 here. So here we go, shading to the left. That's how I show my shading. Next question, part B. Again, just moving the variable terms to one side, so I've decided to move them to the right this time. I end up with 4x on the right. Constant terms are going to go on the left as a result, so I have to add 10 to both sides. That gives me 8 on the left. Now divide both sides by the coefficient of the variable. We end up with 2 greater than x, or x less than 2. So be careful when the variable is on the other side of the inequality that you're reading it properly. X less than 2 means that, first of all, there's no equal to, so you have an open circle, and x is less than 2, so you are shading to the left on this one as well. Let's take a look at the next page. More solving and drawing a number line and doing a graphical solution. So first of all, we need to expand the brackets. So 3 times 2x is 6x, 3 times negative 3 is negative 9. 13 stays here, 2 times x is 2x, and 2 times negative 1 is negative 2. Now we need to simplify. The left doesn't simplify, but on the right, the 13 take away 2 is 11. Now we need to move variable terms to one side, so I've subtracted 2x from the left, subtracted 2x from the right, and the 2x minus 2x is 0, so we just have 11 remaining on the one side, and the 6x minus 2x is 4x. Now, in order to move the negative 9 to the other side, I've added 9 to both sides. So here we have 0. 11 plus 9 gives me 20. And so next we are going to divide both sides of the equation by the coefficient of the variable, which is 4. We get x is less than 5. Now I just see here that I've forgotten to put my number line on, so I'm just going to add that in now. So here is a number line, and I'm going to make a mark on that number line. And indicate that this is where we have 5. Now we have an open circle here because there's no equal to, and its x is less than 5, so we're shading to the left. And that's it for that one. Oh, I guess I should also make sure that I have labeled that this is the x-axis. And then that's it. Now on to part D. Again, we need to expand the brackets 4 times 2x is 8x, 4 times negative 1 is negative 4, negative 5 times x, negative 5x, and negative 5 times 1 is negative 5. Nothing to do on the right. We do need to simplify the left. 8x take away 5x is 3x, negative 4 take away 5 is negative 9. And now since we have the variables on the left, we need to move the constants onto the right, so we're adding 9 to both sides. That gives us 18 on the right. Now we just need to divide both sides by the coefficient of the variable, which is 3. That gives us x is greater than or equal to 6. So again, I need to draw a number line here. So I'll just put a number line down. And I'm going to just make a mark here. And I'm going to indicate that that is where 6 is. This time I'm going to do a closed circle because I do want to include x equal to 6, and it's x greater than 6, so I'm going to shade to the right. And that's that. So now it's asking to do a verification of each solution. Keep in mind that when we're doing a verify or when we're doing a check, you have to check the borderline, or the border point. So that's x equals negative 5. We start with the original left-hand side of the inequality, substitute x equals negative 5, and calculate. Do the same thing on the right-hand side. Start with the original right-hand side, substitute x equals negative 5, and calculate. Now, the border point should make the left-hand side and right-hand side equal. So since x equals negative 5 satisfies the corresponding equation, so in other words, this inequality with this having an equals replacing the greater than, it is the correct boundary point. Basically, it's making the left-hand side and right-hand side equal. So now we want to pick another point that's supposed to be part of the solution. So anything that's less than negative 5, such as x equals negative 6. We start with the original left-hand side, substitute x equals negative 6, and calculate. On the original right-hand side, we substitute x equals negative 6 and calculate. And now we check to see what happens. Negative 21 and negative 24. How do those compare? Well, negative 21 is bigger than negative 24. So the left-hand side is greater than the right-hand side, as it should be. So, with x equals negative 6 satisfying the inequation, it is also part of the solution, which means that we do have the correct solution in x less than negative 5, because the boundary point is correct and we've shaded in the right direction. So for starters, we want to check x equals 13.5. That's the borderline of the solution. Start with the original left-hand side of the inequality, substitute x equals 13.5, and calculate. Okay, now you can do that on a calculator to save yourself a lot of trouble. If you don't know how to do fractions on your calculator, then you do need to talk to me and I'll help you to understand how to use your calculator. But just as a for instance, for me on my calculator, this is what it would look like. So if I want to do 13.5, I could easily do 13.5, but I can also do this. So the 2 2/3 is 2 plus 2 divided by 3. That's 2 2/3. And I want to multiply by, in brackets, 13.5, so plus 1 divided by 2. And now I'm adding 3 to that. And when I calculate, you can see I get 44. On the right-hand side, if I start with the original right-hand side and I substitute x equals 13.5, I also get 44. And here's what that looks like on my calculator for that one. On my calculator, that looks like this. 9 plus 2 times 13 plus 1 divided by 2 for the 13.5 plus 4. And when I calculate it, I also get 44. Now, since the x equals 13.5 satisfies the corresponding equation, this inequality with just equals 2 in the middle, it is the correct boundary point. It makes the left-hand side and right-hand side equal. So what about for x values that are less than 13.5, such as 11? Start with the original left-hand side, replace x with 11, and calculate. Original right-hand side, replace x with 11, and calculate. How do these two compare? Well, 37 1/3 is less than 39. So the left-hand side is less than the right-hand side, as it should be, because it should be either less than or equal to. So since x equals 11 satisfies the inequation, it is also part of the solution. Which means since we have the correct border point in 13.5, and we've shaded the right way to the left for values less than 13.5, that means that x equals, and oops, sorry, this should say here x less than or equal to, I'll just write this in here, x is less than or equal to 13.5 is the correct solution. Okay, so last thing to look at here. So it says the following are wages for 2 summer jobs building grain bins. Job A, you get $60 per bin and you get $120 per day. Job B, you get $75 per bin plus $90 per day. You want to write and solve an inequality to determine how many grain bins you would need to build each day to make job B pay more than job A. So first of all, let's suppose that B is the number of bins that you make in a day. Let's calculate a day's pay. In job A, it would be $120 plus $60 per bin times the number of bins you make. In job B, it would be $90, right, 90 per day, plus you get $75 per bin times the number of bins. Now if we solve this inequality, we want to move the variables to one side, the constant terms to the other side, and divide by the coefficient of the variable, negative this time, so reverse the direction of the inequality, and you have B is greater than 2. So the number of bins must be greater than 2. Therefore, you need to make more than 2 bins per day to be paid more at job B than at job A. That completes this lesson. Thanks for watching this video and have a great day.